Hi, welcome to Send to Print. Today we're going to design a honeycomb patterned card stand. It's a fully parametric design. Modifying the stand's dimensions is just a piece of cake. The best part is you can freely adjust the honeycomb size and the spacing as well. I personally use it for my calendar cards, but you can easily change the parameters to fit business cards, postcards, or even your phone. Without further ado, let's dive right in. First, let's look at the design and some key dimensions. It's a tilted stand with a front lip and a card slot right here. The backplate size depends on your specific cards, so go ahead and measure those first. Now we'll input these into the parameter table, which makes it super easy to adjust everything later. Go to the Modify panel and select Change Parameters. Click that plus icon to add our first one, width. Let's set the backplate width to 210 millimeters. This is just based on my card's width. Next is height. For my 140 millimeter tall cards, I'm using a backplate height of 90 millimeters. It saves filament while staying perfectly stable without tipping over. And then thickness, which we'll set to 2 millimeters. Now for the tilt, let's add angle. Make sure the unit is set to degree, and we'll go with 75. Finally, let's add slot width for the card slot at 6 millimeters. Perfect. Now, right-click the root directory in the browser and select New Component. Let's rename this to Card Stand. Click Create Sketch in the toolbar and select the YZ plane. Use the Line tool to draw a rough outline. I'm using the constraint tools to fix the horizontal and vertical lines, then apply the parallel constraint to the slanted lines. To prevent the stand from tipping over, I want the bottom and back plates' outer edges to align. Draw a line, press X to turn it into a construction line, and apply a vertical constraint. Press D to dimension everything using the parameters we just created. I'll use a few fixed lengths here, 5 millimeters for the front lip height and 5 millimeters for the base thickness. Finally, let's use the collinear constraint right here. Now it looks fully defined, and you'll see that small lock icon on the sketch. If your lines are still blue, it means they're under constrained. We always aim for full constraint to ensure the logic is solid, so the texture won't break when you change parameters later. Let's rename the sketch to card stand as well. Trust me, spending 1 minute here to stay organized saves you tons of time later. Now, press E to extrude. Choose symmetric, switch to whole length, and enter width for the distance. And there we go. The basic shape is done. Before we start modeling the holes, let's take a look at the design logic. We need to define the hexagon side length and the center-to-center spacing. Once we have that, we can calculate the horizontal pitch between hexagons in each row, as well as the vertical spacing along the y-axis. It's just some simple math. Next, we'll estimate the number of rows and columns needed to cover the backplate. Finally, to keep the pattern perfectly centered, we'll calculate the edge gaps using a bit of basic arithmetic. Now, let's input these formulas into Fusion 360. I'll skip the typing process here and just show you the final parameters. One quick tip, for X number and Y number, make sure to select No Units. You'll notice these parameters update automatically based on our main dimensions. This means when we change the stand size later, you won't have to touch these formulas again. Trust me, no one wants to type these twice, including me. Back to modeling. Click Create Sketch on the backplate face. Press P and we're projecting the backplate. Select the backplate. Now let's hide the body for a moment so we can focus on the sketch. Draw 2 hexagons. Constrain these 2 edges to be horizontal and equal. Use shortcut D to dimension their distance to the edges as Y gap and X gap. Then set the side length and hex spacing. Now for an important trick. When the spacing is equal, I mean these green gaps right here, this angle is exactly 30. I could prove the math, but this isn't exactly a math channel, so let's just apply the constraint and move on. I'm drawing a line here, pressing the shortcut X to turn it into a construction line, and then using D to dimension it at 30 degrees. Now the sketch is fully defined. Let's close it and rename it to Hex. Since we've finished the hexagon sketch, it's time to cut some holes. Press E to extrude, select the bottom left hexagon, and set the extent type to object. Then just select the back face of the stand, make sure the operation is set to cut, and the first hole is done. Now, let's use the pattern tool to cover the entire backplate with this honeycomb texture. Under the Create menu, find Rectangular Pattern. Set the object type to features and select that extrusion icon from the timeline. We're using the backplate edge as axes. Don't forget to set the distribution type to spacing. For the first axis, which is our y-axis of the backplate, enter y pitch for the spacing and y number for the quantity. For the second axis, which is the x-axis of the backplate, enter x number and x pitch. Now for the other set of holes, it's pretty much the same. Press E, select the right hexagon, cut it through to the back face. Use rectangular pattern again, selecting the second extrusion. For the first axis, we'll enter y number -1, since this offset row has one less hole, and y pitch for spacing. For the second axis, enter x number -1 and x pitch. And there we go, it's done. The hexagons are perfectly aligned and symmetrical. Finally, let's use the fillet tool. I'm going with a large 5mm radius for these main edges, and a small 1mm fillet for the bottom edges to give it a clean look and help eliminate elephant foot. Now, it's time to see the real magic of parametric modeling. Let's open the parameter table and play around with the values. I'm decreasing the width and the height. Just like that, it instantly transforms into a compact business card holder. My personal favorite part is how you can freely change the honeycomb size and the spacing. But keep in mind, adding too many hexagons will significantly slow down your print because every single hole adds a ton of retractions and extra perimeter paths. I'd suggest checking your slicer's estimated time to find the perfect balance for your design. Oops, that spacing is a bit too small, and now the hexagons are merging. Here's another quick math tip. Try to keep your spacing at least 1.5 times the side length, just to keep everything looking sharp. This model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. And through the parameters table under the Modify panel, you can easily modify these parameters and customize the dimensions. Okay, send to print. After a 2-hour print, I have this beautiful calendar stand. Compared to a solid backplate, I saved a bit of filament, though it did take a few extra minutes to print. When a month ends, just move the front card to the back. If you want to know how I made these calendar cards, keep watching for the next 1 minute. All you need are your photos, and it's definitely easier than you think. Open Canva and find a calendar template you like. Just a heads up, the ones with the crown icons are paid, but there are plenty of great free options too. I've linked the free template I use in the description. Once you're in the template, go to Uploads on the left and bring in your photos. I love using photos from the same month last year so I can see what I was up to back then. Just drag your photo over the placeholder to replace it. It's that simple. If the framing isn't quite right, use the crop tool here to adjust the position. Once you've swapped all 12 photos, you're ready to download and print them out. I use 200 grams of paper so the cards aren't too flimsy. And here's a corner rounder. You can use it to give the corners a professional, finished look. Finally, place them in the stand. Perfect. The Fusion 360 source files, the model, and all the tool links are in the description below. If you found this video helpful, please hit like and subscribe. If you really want to see that 30-degree proof, let me know in the comments, and maybe I'll upload a math video. Just kidding. See you in the next one.